All right, so welcome to my series of videos on managerial economics. And this particular video, it is the third video in the series on consumer behavior. The third video on the series of consumer behavior videos. Now, this video, I'm going to teach on the constraints, several constraints that consumers will be faced with that does not allow them to maximize their satisfaction. Now, if a consumer wants to maximize his satisfaction, he may be faced with so many constraints. One of them is legal constraint. Of course, even though consumers may want to maximize their satisfaction, there are some commodities that by law, you cannot have many. So that alone can form a constraint for you not to have many, all right? Another constraint is time constraints. Sometimes consumers, even though they can afford it, they have a lot of money and they can afford it, sometimes just the time to go around shopping and shopping and shopping to get all that they want will not allow them to do that because they will not get the time. So time can also be a constraint that will limit people from consuming as much as they want and getting satisfaction as much as they want. We can have other constraints like physical constraints, child rearing constraints, etc. But in economics, one of the constraints that we are very certain about is your income or your budget. So here, amidst all the constraints here, we are going to single out budget constraint as a key constraint that limits consumers from obtaining or getting as much as they want to buy and getting the satisfaction level they want. Now, let's look at this scenario here. If a consumer has only 30 cedis in his or her pocket, upon reaching a supermarket, the total value of goods he or she presents to the cashier cannot exceed 30. Why? The reason is simple. The reason is that is his income. So there's no way you have 30 cedis on you, that's all your income. You walk into a shop and you want to buy things worth 100 cedis. You cannot. The reason is that the 30 cedis will serve as a constraint on the number of things you can buy. And that is why your budget can be a constraint to your level of satisfaction. Now here, as we already assumed, what I want you to know is that, you see, if consumers, we already assume that we are consuming only two products in this world, product X and product Y. So here, the total spending on product X, it will be the price of X times the amount of X. So this whole term here is the total spending on X plus the price of Y times the amount of Y. That's the total spending on Y should be less than or equal to your income. So the total spending on X plus the total spending on Y should be less than or equal to your income. Now, based on the assumption that consumers always want to maximize their satisfaction, and also based on the assumption that more is better, here we also assume that we spend all our income on consumption of good X and good Y. And if that is the case, if we are spending our income on good X and Y, it means that the total spending on X plus the total spending on Y is equal to our income. So this function here is called the opportunity set or the affordable set, all right? And this equation here is called the budget line. The budget line is called the budget line, okay? Is called the budget line. So technically, the set of consumption bundle that are affordable is called the opportunity set. And then the bundle of goods and services that exhaust consumer income is called the budget line. Now let's do some small analysis here. Remember that the equation of the budget line is M is equal to PXX plus PYY. So that is the budget line. Now, if you want to draw the budget line on Y and X as products, We're going to draw the budget line like this. It means that we have to make y the subject, because for every equation of a straight line, y is the subject. We're going to make y the subject here. It means we will send this one here. So we have m minus pxx is equal to pyy. And this also means that we divide both sides by py divided by py. So this cancels. We have m minus pxx over py is equal to y. Okay. Then going forward, y is equal to, of course, I can change the position because it's just equal to sign. M minus px x over py. So based on LCM rule, we can now say y is equal to m over py minus px over py x. And if the equation of a straight line is y is equal to a plus bx, it means our a is this term here, and then our b, which is the slope, is this term. So all I want you to know is that the slope of the budget line is minus px over py. The slope of the budget line is minus px over py. The slope of the budget line is minus px over py. So the slope of the budget line is simply minus px over py. And the slope of the budget line is called, so the slope of the budget line is called the market rate of substitution. The slope of the budget line is called the market rate of substitution. The slope of the budget line is called the market rate of substitution. All right. And then by definition, it is the rate at which a consumer can substitute one good for the other and still stay within his budget. And still stay within his budget. The key here is can substitute, can substitute, or he has the ability to substitute. Ability simply means that because it's backed by purchasing power, it's backed by his budget. So somebody's wondering what's the difference between this one and then the slope of the indifference curve. The slope of the indifference curve was called marginal rate of substitution. And for that one, it is the rate at which a consumer is willing. The word here is willing, not able. So it's willing to substitute one good for the other and still maintain his utility. And still maintain his utility. And still maintain his utility. So what I want you to simply know is that marginal rate of substitution is just willingness to substitute one for the other and maintain your satisfaction. But market rate of substitution is your ability to substitute one good for the other and still stay within your budget. So let's get these two concepts clear. Now let's get to the concept of utility maximization. The concept of utility maximization. The concept of utility maximization. Now the example here says that Kwesi is an overworked, underpaid management trainee. His monthly budget is 400, which because he worked such long hours and he spent his money on only pizza and burger. The price of pizza is 8 cedis. The price of burger is 4 cedis. Kwesi's task is to determine the combination of pizza and burger that will yield the highest level of satisfaction or utility from the 400 budget he has, given the prices. The absolute value of the budget line is, of course, remember the slope of the budget line is Px over Py. So here, if it is 0.5, it means burger was put at X and then pizza was put at Y. All right, because the price of X over price of Y would have been 4 over 8. And that is 0.5 here. Now let's look at this diagram. In this diagram, at point A, he can buy 45 units of pizza, as in Y, and then he will buy 10 units of X. Now remember, the price of X is 4. The price of Y is 8. So let's see if this point A can satisfy his budget. So at point A, if he buys 10X, it will be 4 times 10, which is 40. If he buys 45Y, so 8 times 45, that's 360. So you get 400. So point A, it can satisfy his budget. Point B, okay, there are no clear figures at point B. So let's go to point E. All right, let's go to point E. Since the figures are not clear. Point E, he's buying 40X, 30Y. So 4 into bracket 40. And this will give us 160 plus 8 into bracket 30. And this will give us 240. If you add it, it's still 400. And point E as well. I'm sorry, point C, he's buying 70X and 50Y. So it will be 40 into bracket 70 plus 15 into 8 into bracket 15. And you still get 400. So it simply means that point A, point C, point E, all of them are affordable. All of them are affordable. All right. Because they are on the budget line. So you are still within your budget. All of them are affordable. Any point on the budget line means it's affordable. Now, the reason why as a consumer, you must choose point E is that even though A is affordable, point A is affordable, it's on the lowest indifference curve. So it will give you the lowest satisfaction. So point C is better than A because C is on a higher indifference curve and it will give you more satisfaction than point A. However, point E is better than the 2 because point E is on the highest indifference curve among these 3 indifference curves. Among this and that, point E is on the highest indifference curve. It means point E will give you the highest satisfaction and it's still within your budget. Point D would have given us the very, very highest satisfaction, but it's not affordable. So this simply means that always to look at the point where we maximize our satisfaction. It means that the indifference curve must become tangential to the budget line. It must touch it. It mustn't cut through, because if it cuts through, it means that there may be other curves that may be better than where it is cutting through. So here, the point where we maximize our satisfaction is when the indifference curve becomes tangential to the budget line. Now, if the indifference curve becomes tangential to the budget line, it means that at that point, their slopes are the same. At that point, their slopes are the same. So what is the slope of the indifference curve? The slope of the indifference curve is minus change in y over change in x. And then the slope of the budget line is minus px over py. So the negatives here can essentially cancel. And when they cancel, we have change in y over change in x is equal to px over py. But remember, change in y over change in x itself is mu of x over mu of y. So technically, the utility maximizing point occurs at where mu of x over mu of y is equal to px over py. So this is the necessary condition. The necessary condition for you to maximize your utility. But remember that for the sufficient condition, the necessary condition must exhaust your budget. So for the sufficient condition, what we are saying is that the necessary condition must exhaust your budget. So for the sufficient condition, the necessary condition must exhaust your budget. Okay, the necessary condition must exhaust your budget. All right. Now, let's give another interpretation of the of the necessary condition. Another interpretation of the necessary condition. Remember, it is mu of x over mu of y is equal to px over py. So if you juggle the formula around a little, you now have mu of x over px is equal to mu of y over py. All right. So we are going to give another interpretation of the necessary condition. This interpretation here simply means that the additional satisfaction we obtain from spending a CD on X. So this concept is mu of X over Px. Should be equal to the additional satisfaction we obtain from spending a CD on Y. And that concept is mu of Y over Py. So the additional satisfaction we obtain from spending a CD on X should be equal to the additional satisfaction we obtain from spending a CD on Y. Now, what happens if we have something like mu of X over Px being greater than mu of Y over Py? When this happens, what this technically means is that when this condition happens, it means that the consumer is not optimizing utility. So what should he do? So of course, if this side is bigger than this side, means that every CD he spends on X, he gets more marginal utility than every CD he spends on Y. So because the marginal utility of X over PX is greater than that of Y. So it means every CD he spends on X, he gets more marginal utility than every CD he spends on Y. So what should he do? As an rational consumer, he should continue to spend more on X. As he consumes more of X, the marginal utility of X will diminish. Remember the law of diminishing marginal utility. So he should continue to spend more on X. But as he consumes more of X, the marginal utility of X will diminish. So it means that this thing in the fraction will diminish. And if this in the fraction diminishes, it means the whole fraction will diminish. All right. So this will diminish until, so if the whole fraction diminishes, it means that to get to the point where, so until it restores to equilibrium. The reason is that if this part of the fraction is diminishing, it means that it will become small and small till the time that it will now equate the other one. So we now have mu of X over Px is equal to mu of Y over Py, right? Okay. So remember this condition very well. Now let's take an example on this very condition. So here, if the marginal utility of X is 30, marginal utility of Y is 30, price of X is 6, price of Y is 5. The question we ask ourselves is that, is he consuming in an optimal manner? So we have to check. So mu of X over Px, mu of Y over Py. So this is 30 over 6 and then 30 over 5. So 30 over 6 is 5 and then 30 over 5 is 6. So 5 is less than 6. All right. And the interpretation here means that every CD spent on Y yields marginal utility of 6 as compared to that of X, which is 5. 6 utils, of course, then 5 utils. Therefore, he should continue to buy more Y. As he does this, diminishing marginal utility will set in until the condition is restored to equilibrium. All right, so that is what he has to do. Okay, so this will bring us to this particular third video in the series. And in the next video, I'm going to pick practical examples on how to maximize utility. So kindly like, share, comment, and most importantly, subscribe to the channel and recommend it to others too. Thank you.